Hello, friends. How are you? I hope you are doing really good. This is the structure, and in the today's video, we will see how to idealize this complex structure into simple form so that we can analyze it. So, let's get started. Engineering Fundamentals References NPTEL by Yuvandhara Tayale. Content of the video is Introduction, Structure Idealization, Truss, Frame, and Threads. Idealization of structures, threads, and responses. Friends, do you know the story of Three Little Pigs? Story? Yes, the kids' story of Three Little Pigs. And do you know? One of the pig is a civil engineer. So let's see. The little pigs were grown up and they wanted to live their own life. So they asked their mother, Mama, can we go and have our own life? Can we go? Their mom permitted them. So they went to another city to live their life as a grown up. So, for living in the city alone, away from our home, they first need to build their own home. So, the little pigs were started building their home. So, first pig was really lazy. He just gathered the dried grass around and built his house in just 2-3 days and started enjoying his life. Started singing, playing guitar, and wandering here and there. Then second pig, he took dried weeks and built his home in a week. And then he also joined the first pig and started enjoying his life. But the third pig, he was as a civil engineer. He was thinking a lot, planning how to build his house, how to protect his home from all the dangers. And the two pigs were laughing at him. Ah, we don't need such home. We are all protected. But the third pig planned well and built his house with the help of bricks, concrete, mortar. And you know, their enemy, wolf, was staring at them. So let's see what happened next. So the three little pigs built their own homes and started living in their own homes. So you can see the house of first pig was made up of dried grass. The house of second pig was made up of dried twigs. And the house of our civil engineer, it was made with the help of bricks and cement concrete. It was well protected from all the threats. Here comes their enemy, the bad wolf. And you know, he wanted to eat all of the pigs. So first he went to the pig whose house was made up of dried grass. And very easily He broke that house. The first pig ran to the second pig, and they were all frightened. They didn't understand what to do. With the help of some strokes and some stones, Wolf blew away the house of second pig as well. So these two pigs were on the streets in front of this wolf, didn't understood what to do. They went to the third pig, whose house was made up of bricks and cement mortar and well planned, and they were protected there from this wolf. So, from this story, we understand the importance of planning against all the threats. So, what are these threats and how to plan our structure? We will see. So, here, these are the threats. Some natural calamities like wind, earthquake, they make our house, our structure ill. We need to protect them and see the response of our structure. So, this is called the forward analysis. Structure idealization. You know, the physical system is really complex in nature. We cannot solve it or analyze it as it is. So, we convert that physical system or idealize that physical system into its simplified form, that is nearer to or closer to this physical system. Like here, for example, this geometrical shape is idealized as ellipse. Now, this idealized system is converted into the mathematical form. Mathematical equations, which can be integral, differential equations, which represent our physical system, very close representation. And after solving this mathematical problem, we get our solution of how exactly we can replicate this system, how exactly we can solve this system. Structure idealization. Now, when we idealize a system, we have to idealize everything. That is, we have to idealize the real structure and the threads, those are acting on it. So, here we will first see the structure idealization. In the picture, you can see it is a chimney. Now, this real structure is idealized like this. What you can see a line which is fixed at its support. So, what are the assumptions? Now, this chimney is really tall structure. Its length is really long as compared to its cross-sectional dimension. So, we can consider it as a line. And as this chimney is fixed to the ground, we considered here as a fixed support. So this is the idealization of this rear chimney as one single line structure which is fixed at its end. We will see another example of structure idealization. In this picture, you can see overhead water tank. It is similar to chimney. It is slender up to here and water mass or weight of the water is concentrated here. So we considered it as a line element and lumped mass of water is being represented here with fixed support at its end. This is the third example of structure idealization. You can see here a truss bridge and it has been modeled or the mathematical model of the truss bridge or the idealized structure is shown right hand side. This every member is shown in the idealized structure and it is considered as a line member. This is the idealization of the frame model. Building frame is modeled like a line members of beams and columns. It is idealized. Structure truss. These are some of the photographs of showing truss, bridges, and this is also the example of truss. These are real life examples. Now, in this picture, you can see it as a space truss. This is the line diagram. The lines are marked for the members, and the similar truss is there on the other side. And these two trusses are joined by the members. So it is a three-dimensional. So it is called a space truss. For our idealization, we consider it as a two-dimensional with line elements. Frame. What are frames? This is the frame of house, buildings. This is the difference between truss and frame. In the subsequent videos, from the engineering mechanics point of view, we will see beams, cable, truss, and frames. This is a space frame, similar to the space truss. These plane frames are joined by members to form a 3D structure called space frame. We have idealized it as a collection of line members in 2D with fixed supports or the supports according to the given by structural engineer, and we call it as a plane frame. Thank you so much to you all for being with me throughout this video. Happy learning! I'm grateful for your support. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.